Let's see how we can derive these equations of motion by graphical method. Let us start with the first equation. Equation for velocity-time relation. Consider this velocity-time graph, where time is taken along x-axis and velocity is taken along y-axis. According to this graph, the object starts at point A with an initial velocity of u and moves with an uniform acceleration. And the final velocity is v, marked at point B in time t. Let the change in velocity at a uniform rate be a. Draw two perpendicular lines BC and BE from point B to x-axis and y-axis respectively. Now OA is initial velocity, BC is final velocity, and OC is time interval t. The change in velocity is shown by the line BD, where BD is equal to BC minus CD. Now, let's draw a line AD parallel to OC. We can see from the graph BC is equal to BD plus DC is equal to BD plus OA. Now, we can substitute the value of BC and OA in the previous equation to get V is equal to BD plus U. BD is equal to V minus U. From the graph, we can find the acceleration A is equal to change in velocity upon time taken, which is equal to BD upon AD, which is equal to BD upon OC. Substituting OC by T, we get A is equal to BD upon T. BD is equal to AT. By substituting the value of BD is equal to AT in BD is equal to V minus U, we get V is equal to U plus AT.